Hey everyone, welcome back. Another type of reaction that we're going to talk about today is the double replacement reaction. It is amazing. That means not one, but two things get to switch places. We're going to start with two different compounds. We're going to finish with two different compounds. All right, so two things do replace each other. This is going to happen when we have ionic compounds. Usually, these ionic compounds are dissolved in water. Okay. So that's an aqueous solution. When we take something and dissolve it in water, it forms an aqueous solution. For example, we have sodium hydroxide and iron 3 chloride right here. Both of these are going to be aqueous, they are dissolved in water. We're going to take this sodium hydroxide. We're going to take this iron chloride and we're going to switch some things. We're going to switch the metals or the cations. They're going to be in different places. So the positive, the cations, are what's going to change places. So the sodium right here, is now going to change places with the iron. So the iron is now going to be with the hydroxide, and the sodium is going to be with the chloride. We're going to have to remember how to write our formulas. We learned that in the fall. If we look up on the periodic table, the iron can have a +3 charge. Hydroxide from our polyatomics list is going to have a -1 charge. Sodium is going to have a +1 charge. We get that off the periodic table. And chlorine is going to have a -1. That's right. We're going to cross our charges. When we cross our charges, we end up with this FeOH3. So this 3 goes on the outside of the parentheses, and NaCl. So that's what we do. The cations switch places. After this, you do have to balance the reaction, just like we've been practicing for a while. But this is the basics. The positive ions or cations change places. All right. In a double replacement reaction, this only happens if one of the products doesn't dissolve. Okay. That means it is a gas or a solid or forms something covalent, so it separates. Like oil and water, they don't mix, they separate out. That's what it's talking about with that. So things that are this is going to be our solubility. So things that are soluble, like ammonium, this polyatomic ion, if you have a compound with ammonium in it, it's always soluble. No exceptions, always soluble. Here are our exceptions, or our normal ones, no exception here. Bromine is always soluble unless it's with silver, mercury, or lead. Okay. So bromine, so like silver bromide, that's not soluble. Mercury bromide, not soluble. Lead bromide, not soluble. Anything else, soluble. Chlorine and iodine are the same. So chlorine is always soluble unless it's with silver, mercury, or lead. Okay. Nitrate, always soluble. Sulfate. Sulfate is always soluble unless it's with strontium, barium, mercury, or lead. So there you go. A lot of these things are always soluble. Just pay attention to the exceptions. These things are always insoluble, like carbonate, always insoluble unless it's with ammonia or ammonium ion, I should say, or alkali metals. So we're going to have to look back at our periodic table and remember what the alkali metals are, like lithium and sodium and potassium. Those are our alkali metals. All right, column 1. Hydroxide is not soluble unless it's with an alkali metal or with calcium, strontium, or barium. Okay. Phosphate is not soluble unless it's with ammonium ion or an alkali metal. Remember, alkali metals, column 1, lithium, sodium, potassium, etc. Sulfur, not soluble unless It's with ammonium, alkali metals, calcium, strontium, barium. You're seeing a trend here. Chromate, same thing. Not soluble unless it's with ammonium or the alkali metals. All right, so let's look at this next page. Same chart right here. We're going to have our first thing. We have calcium chloride. Okay. Chlorine, right down here, is always soluble. Let's see. We're going to get out our pen right here. Calcium is always soluble. Or sorry, chlorine is, unless it's with silver, mercury, or lead. So calcium with chlorine, we could just put AQ because we know that it dissolves. Hydroxide is not soluble unless it's with an alkali metal. Sodium is an alkali metal, so this right here is soluble. We can write AQ. And that's what this chart does. It tells us which things are soluble and which are not. Now we're going to switch some things around. The calcium and the sodium switch places. Sodium is now going to be with chlorine. So we have sodium with chlorine. Sodium has a +1 charge on the periodic table because it is in group 1. Chlorine has a -1 charge on the periodic table because it is in group 17. +1, -1, they cross, and we get NaCl. Chlorine down here is soluble unless it's with silver, mercury, lead. Sodium is not one of those, so we're going to say AQ. And then we have plus. Now we're going to have calcium is going to mix with the OH. So hydroxides. Hydroxides are not soluble unless it is with alkalis or calcium, strontium, and barium. So we have calcium hydroxide. It's going to be Ca. Then we're going to throw in this OH2. So that's how you would fill it out. This is aqueous. And it's not actually going to happen because it's all aqueous straight across the board. Whoa. Let's try this next one. Copper 2 chloride plus potassium sulfide. That's right. So we are going to get some things right in here. We're going to see if these are aqueous or not. Copper 2 chloride. Let's see. Chlorine. Chlorine is soluble unless it's with silver, mercury, or lead. It is not right here, so we can say AQ. Aqueous dissolves like a champ. K2S. That is, oh, do we have a sulfur? Yes, we do. But it is with an alkali metal. Potassium is an alkali metal, so it will dissolve. That's the exception. So AQ. All right, the copper and the potassium switch places. So now we have potassium with chlorine. So we have K. K on the periodic table is from group 1, has a +1 charge. Cl is from group 17 on the periodic table. So that's Cl. -1 charge. +1, -1 cancels out. All right, so we have KCl. And we look on here again. Chlorine is soluble. So we're going to write AQ. Put that in parentheses. All right. Very good, very good. And over here, we're going to have copper with sulfur. Okay. Copper has a +2 charge, so we have Cu. And sulfur has a -2 charge. Copper has a +2, sulfur has a -2. +2 -2 cancels out. So let's look down here. Sulfur is not soluble unless it's with ammonium. We're not with ammonium. It is not with an alkali metal. Copper is not in group 1, not an alkali metal. And calcium, strontium, barium. It is none of those things. So this is now going to form a solid or a precipitate. So we put that S there. So this reaction does happen because we form a solid. All right. Next thing we have to do is we have to balance. We have 1 chlorine over here. We have 2 potassiums over here. So if I put a 2 right there, now I have 2 chlorines, 2 potassiums. Everything else in here is equal. So the only coefficient needed was right there. All right. Another practice problem right here. Let's see what we can figure out. We have potassium hydroxide plus iron 3 nitrate. Okay. Whew. A lot of stuff here. So hydroxides are not soluble unless they're with alkali metals. Potassium is an alkali metal. It's in group 1. So we're going to write AQ. Okay, nitrates. Right there, nitrates are soluble. Always. So no matter what metal it mixes with, this NO3, it's always soluble, AQ. So we're going to put that there in parentheses. Now we're going to have potassium with nitrate. So K NO3. Potassium has a +1 charge. If we look on our polyatomic ions list, nitrate has a -1 charge. +1, -1, they cancel out. Nitrates are always soluble, so we're going to write AQ. Just like that. Boom. And then we have iron and hydroxide. So iron and hydroxide. Iron has +3 charge. Hydroxide has a -1. The 3 comes across over here. Put it down at the bottom, just like that. So we have iron 3 hydroxide. Now we're going to look down here. OH is not soluble unless it's with an alkali metal, calcium, strontium, barium. Iron is not an alkali metal. It is not calcium, strontium, or barium, so it's going to form a solid, a precipitate. Just like that. So I put an S there. Now I just have to balance. So I'm going to put a 3 right here. I'm going to put a 3 right here. And now we are all balanced up. Okay. That's what it is. We have to be able to look at this solubility chart to determine if we have precipitates forming or not. The other thing we have to do is we have to be able to write our products just like we did here. Crossing charges, all that. And then balance. So there's a few more steps on the double replacement reactions. All right. There is a practice assignment as well. Get going. Good luck. You're going to be great.